Hello all. So yesterday we went over rate of change and how we find it. Today we're going to take that rate of change and write linear equations. So our topic of the day is writing linear equations. A learning target. Today I can write a linear equation by finding the rate of change in initial value. Let's start off with some essential vocabulary. So as you can recall, linear equations are equations between two variables that gives a straight line when plotted on the graph. So when you plot a linear equation, you will always have a straight line no matter what. It can never be a curve or anything else. Rate of change, we went over this yesterday. It can be defined as a rate that describes how one quantity changes in relation to the other. I gave an example of cars driving at 40 miles per hour and show how the distance and the time is a relationship between each other and how that represents rate of change. Initial value, it is the starting output value of a function. And if you can recall, in class, I usually refer to this as our starting value. What is our start? What are we starting with? What are we beginning with? What are we having in the beginning of any situation? So, linear equations are usually written in the form y equals mx plus b, where m represents your rate of change and b represents your initial value. Taking a look at their linear equation below, we see that we have y equals negative 2x plus 3. The negative 2, our coefficient, is our rate of change, m, and the positive 3, our constant, is our initial value, positive 3. So let's start some practice. Problem number 1. The equation and table show what two boys pay for gym fees. Compare the rates of change in initial values for each functions. So first things first, I want to list out my given. I see that Alfredo on the left side has a table, and Alex, they're already given us in the linear equation, and the question is asking us to compare the rate of change and initial value of each functions. In order to compare, I have to know what the rate of change and initial value is of each. So let's start with Alfredo's side. Remember on the previous slide, I said that each linear equation usually comes in the form y equals mx plus b. Let's start with m, our rate of change, which we went over yesterday. First, we choose our 2 points. I'm going to choose 0, 20, and I'm going to choose 1, 30. So we have 0, 20, and we have 1, 30. After we choose our 2 points, I want to identify my x1s, y1s. 0 is my x1, 20 is my y1, and my x2, y2, 1 is my x2, 30 is my y2. And let's recall our formula for rate of change, which is m equals y2 minus y1 over x2 minus x1. I'm going to take these 2 points and substitute it in the formula, and I get m equals y2, which is 30, minus y1, which is 20, over x2, which is 1, minus x1, which is 0. 30 minus 20 is 10, and 1 minus 0 is 1. So our rate of change is 10 divided by 1, which is 10. So right now, at the moment, we have the equation. I'm going to take this 10 and substitute it in place of m up here, and I have y equals 10x plus b. Now all we are missing is our initial value, b. So if you remember in the definition, it said that the initial value is the starting output value of the function, meaning look at your input, the months, and find 0. That is the starting input value. To find the starting output value, you look out the output value for x equals 0, which is y is equivalent to 20. So our initial value is 20, is our starting output value. So I'm going to take this 20 and substitute it in place of this b here, and I have y equals 10x plus 20. Now let's look over at Alex's side. So they already given us an equation. C equals 25 plus 10m. Even though we don't have the same variables, we can still compare the rates of change, and the initial values. So let's start with the initial value for Alex. So the initial value, our constant for Alex's problem, is 25. And his rate of change is equivalent to 10. So I see that Alex has an initial value of 25 and Alfredo has an initial value of 20. So Alex initial value is greater than Alfredo's initial value. Now the rate of change, I see that Alex has a rate of change of 10 and Alfredo has a rate of change of 10 as well. So Alfredo rate of change is equivalent to Alex rate of change. So to answer the question, I know this may be a little sloppy, but I'm working with a small amount of space here. So to compare the rate of change and initial value for each function, I stated that Alex's initial value, which is 25, is greater than Alfredo's initial values, which is 20. And to compare the rate of change, Alfredo's rate of change, which is 10, is equivalent to Alex's rate of change, which is 10. So, as usual, you're going to have a problem that you have to solve on your own. This is your problem for the day that you have to answer within the classwork. Please take a screenshot if you're viewing this on your cellular device, or you can jot it down and solve it on a piece of paper and write your answer down in the classwork on the space provided. Bye.